Okay, so in this video we're looking at 2019 SEC Higher Level Maths, Leaving Cert Paper 1, Question 5, and it's a complex numbers question. So it says 3 plus 2i is a root of z squared plus pz plus q is equal to 0, where p and q are elements of or and I squared is equal to -1. Find the value of p and q. Okay, so the bits in yellow here that I've highlighted, I've actually introduced, the question doesn't have a coefficient on the z squared, but I introduce a 1 here just to remind you that all the coefficients, so the numbers in front of the variable, so the 1 and the p are real, and q, the constant, is real. So all real. So all the coefficients and the constants are real, so we can use the complex conjugate roots theorem. So that complex conjugate roots theorem states that if the coefficients and the constant are real, and we know 3 plus 2i is a root, then we also know that the conjugate, z conjugate, which is 3 minus 2i, is also a root. So there's two ways in thinking of this. We could state that with most quadratics, or with all quadratics, that the q, the constant at the end here, is the product of the roots. So you could say these two multiplied together would get you q, or, and following that, you would say that the coefficient of the variable in the middle, just the z to the power of 1, the coefficient of that, the minus the coefficient, so minus p, would be the sum of these two. So if you added these two together, what I like to think of is that if we know roots satisfy the equation. And what that means is if I were to sub in the root, so I'd subbing in the first root in for z, and I multiply it out, it should mathematically make sense. So I've just continued to multiply it out. So 3 plus 2i squared, and so 3 by 3 is 9, 3 by 2i is 6i, 2i by 3 is 6i, so that gets us to 12i. Plus by plus is plus, 2 by 2 is 4, I by I is I squared, and note that I squared goes to -4. So all of that's just being simplified there. This section is multiplied out, and there's nothing too magical about that, and we're continuing with the q at the end. How many unknowns do I have? I've p and q. Okay, so I'm not able to solve this yet because there's two unknowns, but only one, there's two unknowns, but only one equation. So I must be able to have another equation somewhere. So that's my equation 1 here. Equation 1 here. Where's the second equation coming from? Well, I know this is also a root. So if I were to sub it in for z, it should make sense. It should satisfy the equation at the end of the day. So I again go and multiply that out. This is very similar in multiplying out. In fact, it's identical when I multiply it out, bar the fact that I have a -12. Okay, -12i. The second part, what color can I use? Light green. This is, I want green. This is getting multiplied out. And I've gotten myself to a second equation now with two unknowns. What are the two unknowns? P and Q. So that's brilliant. That's a second equation. So I bring those up to here. Two equations with two unknowns. I can subtract them. Okay, so changing the signs of everything here, plus, minus, plus, minus. 3p minus 3p is 0. 2pi plus 2pi is 4pi. Q minus q is 0. Minus 5 plus 5 is 0. Minus 12i minus 12i is minus 24i. And I have, what is it? pi. So I've divided everything by 4 here. And now I'm dividing everything by I. So I now know what p is. Brilliant. If I know what p is, I can come back to either equation 1 or equation 2. It doesn't matter which one I come back to, either equation 1 or equation 2, and isolate Q. So you can see, which one did I use? I used equation 1, and while I was rewriting this, I subtracted minus 3p minus 2pi from both sides. You can see it here now, they're minuses, so I've subtracted it from both sides. And filled in my p, so I know p is minus 6, so I'm filling that in here and here, because I know p is minus 6. And I've only one unknown now, which is the q. So it all multiplies out to getting q is 13 and p is minus 6. How do I know that's kind of right? Remember, they're real. P and q should not have i's in them. They are real. P and Q should not have i's in them. They're real. So 10 mark question, 0, 4, 7, 10. Quite a nice question, to be honest. Okay, the next part was a changing to polar form. So they give you a complex number and they want you to write it in polar form for 5 marks. If you've done any revision of complex numbers, like, this is a gift of a question. You should really be able to do this. So step 1 is always draw out your argand diagram. You know it's going to be 2 on the real axis and minus 2 root 3 on the imaginary axis. We know we need to get our argument, or is our modulus, we need to get our modulus using our modulus formula. So we're subbing in what we know A is, which is 2, and B is minus 2 root 3. Multiply it out and we get 4. Fantastic. And we need to get our argument, which is this red angle here. Remember, it's always measured from the positive side of the real axis. So it's this red bit that I want. Okay, but it's difficult to get that red bit. So I decide to draw this triangle out here. That triangle, which translates over here. And I get or, the reference angle. I know with a right angle triangle, I know it's going to be tan because it's opposite over adjacent. Remember, I know the opposite, I know the adjacent. And then I can get tan inverse of root 3 to get or is 1 over 3 pi radians. Okay, well, how does that lead to getting what the red angle is? Well, if you look at this brown guy, that's a full circle. How many degrees in a full circle? 360 degrees. I know pi is 180 degrees. I know 2 pi is going to be 360 degrees. So does our red angle look bigger or smaller than 360 degrees? It looks smaller than 360 degrees. So I'm going to have to go I'm going to have to go 360 degrees minus that purple bit. But we want to deal in radians, so we're going 2 pi minus that purple bit. So that's where the 2 pi minus 1 over 3 pi is coming from. And with your calculator, that'll get you 5 pi over 3. Make sure your calculator is in radians. And then all you have to do is sub it all in to that right there. We know what our or is. We know what our theta is. Okay, so the next part of the question is going to utilize V and utilize this in polar form. So utilize V in polar form. So the question states that W squared is equal to V. Okay, so just let's take a second and think. What if I had X squared is equal to 4? Well, what I would do to get X on its own, I would take the square root. Whoops, come back to me. I would take the square root of both sides. The square root of X squared is just X. The square root of 4 is plus or minus square root of 4. Because I must have 2 answers. Remember, the highest power is 2. So I should have 2 solutions to this. Okay. So also we know from page 21 of our log tables that the square root can be written as the power of a half. And then I'm getting 2 and minus 2. The square root of 4 is 2, but I want 2 answers, so I'm getting 2 and minus 2. And just check, if you squared minus 2, you would get 4. If you squared 2, you would also get 4. So I know that W squared is equal to V, which was my answer to the first part. W squared is equal to this, which is my V, which is my answer to B part 1. W squared is equal to this. But I want to get W. I want two answers, two possible values. So if I get the square root of this right hand side, well, a square root can also be written as a power of a half. Okay, well, I've got power of a half in complex numbers. Your brain should be screaming something here. Power of a half in complex numbers. You need to think general polar form. Think GPF. General polar form. And that is by adding on our 2n pi. 2n pi and 2n pi. Now it's in general polar form. Now I apply De Moivre's theorem, which brings us to here. De Moivre's theorem says the modulus to the power, the argument by the power. Modulus to the power, argument by the power. 4 to the power of a half is 2. Multiplying these in, we're going to use multiplying fractions. So it's top by top, bottom by bottom. And then a half by 2 is 1. Top by top, bottom by bottom to get your 5 pi over 6. And then a half by 2 is 1. So we're just getting n pi or 1n pi. What values of n am I going to use? Well, how many answers should I have? I should have 2 answers. So I'm going n is equal to 0 and n is equal to 1. So here we're using our n is equal to 0. Subbing in 0 and multiplying it out. So this really just reads cos of 5 pi over 6 and sine of 5 pi over 6. Use your calculator to type that in. You'd get minus root 3 over 2. Use your calculator to type sine of 5 pi over 6 in. You get a half. You then need to multiply in by the 2 and you're getting w is equal to minus root 3 plus I. We also need to use n is equal to 1. Okay, brilliant. Subbing n is equal to 1 in here. We're just getting pi. So it's cos of 5 pi over 6 plus pi, making sure the brackets are in the right place when you're typing that into your calculator. You get root 3 over 2, and sine of 5 pi over 6 plus pi, you're getting a half, or minus a half. And then multiplying by the 2, and you have your 2 answers for W. Okay, 10-mark question. Actually, just a lovely question all around for complex numbers, so you should really be happy with that, in all honesty. Hopefully you found the video useful.